All right, so problem number 2, we have a golf ball drop from a height. Now, on a lot of these problems, we actually don't calculate the speed by using any kind of dynamics equation. Instead, we're going to use kinematics, and in this case, since we don't have time, I will use the following equation. And when we actually do this, this is going to wind up being v squared equals 0 squared plus 2 times negative 9.8 times 0 minus 1, because the initial height is 1 and it lands at 0. When we simplify, we're going to get v as 4.43 meters per second. Now I'm going to make one little simplification here. I'm going to actually say that v is negative 4.43 meters per second. And what we do when we do that is we're saying that downwards is negative. Very important point. Now we want to calculate the impulse of the ball during the bouncing process. What do we mean by the bouncing process? We mean the 0.0018 seconds during which the upward force from the floor is 218 newtons. So we calculate the impulse in the following manner. And when we do that, we're going to actually end up getting 0.392 newton seconds. Finally, to get the rebound speed after the ball leaves the floor, we're going to use the impulse momentum theorem, as well as our results from A and B. So we're going to get 0.392 for force times time, that's what we just did in B, equals the mass, 0.046, times its final speed, minus 0.046, which is the mass of the golf ball, times its downward speed, which is negative 4.43. Now when we simplify, we're going to end up getting that v is positive 4.1 meters per second. In other words, the ball bounces, hits the ground, and bounces back up at 4.1 meters per second.